Hey guys, so this is a example practice 7, which is on page 00 on your packet. This is an example of a coordinate proof. So this coordinate proof says that prove that you have an isosceles triangle and that the altitude is the perpendicular bisector of the base. So we talked about the first thing you have to do is you have to draw an isosceles triangle. Now you could have drew an isosceles right triangle or an isosceles triangle that looks like this. So I'm going to call this 0, 0 and call this point A. This point right here would be P comma Q, which I'll call point B, because you go over, I'm just going to say that you go over P up Q, and then if this is isosceles, that means you're going to, the same distance you move here, you're going to move more the same exact distance that way, and if from here to here is P, then this would be 2P comma 0, and that would be point C. So first of all, we have to prove that this is an isosceles triangle. So to prove an isosceles triangle, we're going to find the distance from AB, and then also find the distance from CB or BC. So I'm going to use the distance formula. And if you subtract the x's, so P minus Q is just P squared plus Q minus 0, which is just Q squared, gets us P squared plus Q squared, square rooted, and that's as far as you can go because you cannot individually square root them. So that's the distance from A to B. So CB is going to be 2P minus P squared plus, and then 0 minus Q squared. And the whole thing's under the square root sign. So 2P minus P is P. P squared is just P squared. Negative Q squared is actually, it's -1, and both the -1 and the Q get squared, so you end up with a positive Q squared, +1 Q squared, all under the square root. So right here, you can see that since they have the same exact distance, that proves that we have an isosceles triangle. So the next thing is to prove that the altitude is the perpendicular bisector of the base. So to draw an altitude, we're going to go ahead and drop a right angle. And from here to here, we know that if you go straight down, you're going to hit directly between here and here, which would be at the point P comma 0. So to way to prove that's a perpendicular bisector, because this again is the height, because you go straight down, we're going to first make sure that this is actually at a perpendicular angle. So we're going to use the slope formula, and I'm going to call this point D. So the slope of line BD is we're going to do y minus y, so I'm going to do q minus 0, which is just q, and then p minus p, which is 0. Well, anything divided by 0 has an undefined slope, which means this is a vertical line. So the slope of this line, which would be AC, I'm going to do y minus y, so 0 minus 0, which is 0, and 0 minus 2p is negative 2p. Well, 0 divided by anything is 0, and if the slope is 0, you know it's a horizontal line. Well, this right here proves if you have a horizontal and a vertical line, horizontal and vertical lines are always going to be at a perpendicular angle. So that proves that you do have a perpendicular. And now to prove that's the bisector, that would prove you could find the distance from here to here and find the distance from here and show how they're the same. Or I'm going to go ahead and find the midpoint of AC. And the midpoint of AC would be if you add the x's, so 2p plus 0 is 2p divided by 2, comma, y plus y divided by 2. 0 plus 0 divided by 2 is just 0. 2p divided by 2 is p comma 0. And now this would prove that if you look at the point p comma 0 is the actual midpoint, which would prove that it is the bisector of line AC. Please look, there's other videos of coordinate proofs on Westland Math under this chapter 5 or unit 5. Go ahead and make sure you check out all of them.